Another important intuitive idea is how do we define a left-handed limit and a right-handed limit um, in a similar way to the previous video where at the end I described what is a generic idea of a limit. Um, but sometimes we want to look at it only from one side, not as a both-sided thing. And as I said with the negative in the exponent, we always refer to this as a left-handed limit, where the limit as x approaches a from the left of f of x is equal to L. If from that left-hand side, it looks mirrored on the video, doesn't it? So from the left-hand side, what's it getting close to? That would be our limit from the left-hand side. Whereas from the right-hand side, it may have a different limit. And we would say that it would get sufficiently close to the value of L from either side. Specificating using the little negative in the exponent versus the little positive in the exponent. And analogously, we would say a right-handed limit would look like this instead. Kind of like how I said it, with 1 over x, it approached infinity from the right and negative infinity from the left in those specific cases. And we'll practice using this notation as well. But generically speaking, I mentioned this before, we say that only a generic limit, the limit as x approaches a of f of x equal L, if and only if, meaning that this will only be the case if the left-handed limit equals L and the right-hand limit equal L. So like in our previous example, the left-hand limit of the parabola that at that specific point was headed towards 4, and also the right-hand limit was headed to 4. Since both of them headed to 4, we'd say that the generic limit, again, my head's in the way, of f of x was equal to 4 there. And this is an important principle to remember with general limits. You have to check both directions to make sure it's the same on both sides. And again, looking at a graphical perspective, you would check a left-handed limit by looking, well, what's happening from the left-hand side? What's it getting closer to? And a right-handed limit would be taken from the right-hand side. And they don't need to, you could define them separately and determine those limits separately, but only if both of those are the same thing, then it makes a generic limit. And we might refer to it as LHS or RHS, or left-hand side LHS or RHS, if I'm ever trying to specificate left-hand side versus right-hand side. So let's do an example of a graphical limit, and let's practice using the notation as well. And really, if you want a very step-by-step way of doing this, step 1, if you're trying to do a graphical limit, make sure that you have a graph of the function at least nearby the limit to which you're trying to determine. So let's say we wanted to determine these limits down here. The limit as x approaches 0 from the right of cosine of x. And in this class, we're not going to be working with trigonometric functions such as sine and cosine often. But if we have a graph, it doesn't really matter. And so if you don't really remember how these work too well, it's fine. We're going to not be using trig much, if at all. But it's at the end of the day, if we have a graph, it doesn't matter. You can always create a graph with your graphing calculator, or something, or by hand if you want to as well. And so step 2 says examine the limit from the left and the limit from the right. This can be done by using the wall method that I described before and looking at tracing the curve from the left hand side and the right hand side, kind of trying to see, well, what's happening from each direction. And step 3, if the limits are the same, you have your limit. It should be the y value where those meet up. And if they don't meet up in the same point, or if one or both do not exist, we'd say the limit does not exist either. So let's go ahead and do it with cosine. And so first of all, we want to look at where is the limit targeting. So this one says the limit as x approaches 0 from the right, and then it also asks us what's the limit from the left, and then what's the generic limit. Sorry, that says x approaches 0. Sorry, it's a little bit cut off. My slides are a little bit bigger than they should be for online modality, but it's fine. But basically, x is targeting 0. I want to know what's happening as x approaches 0 with all of these, whether it's from the right, from the left, or generic. So again, you could, if you were trying to use the wall method, you could draw a wall through x is equal to 0, which in this case is the y-axis, right? Because x is equal to 0 right here at the origin, and basically we would be looking at what's happening as it approaches the y-axis. Now let's say we wanted to know what happened as x approaches pi. we would just draw a wall through pi instead, or wherever along this curve, any point that we would need to. But again, trying to, don't worry about trigonometric functions for the sake of this class. But again, we're not worried about pi, so let me erase that. So as x approaches 0, well, again, the little plus means from the right-hand side. So basically, I would need to be looking at it from the right of the wall and think about as it's getting closer and closer. And notice that I'm actually moving left as it's going from the right, because I want to know what's happening as it's getting closer and closer to 0 from the right, which ends up being a leftward motion. So that can sometimes be, it can be easy to get mixed up if you see what I'm saying, because we're really moving to the left, but it's from the right hand side. And what I could see is it's getting closer and closer to the value of 1. That would be what's apparent from the graph. And numerically speaking, if we were trying to do that, you would want to plug in values close to 0, say 0.1 or 0.01. And again, slightly to the right of those values. Now, the left-hand limit, same sort of idea. We would look at what's happening from the left, moving to the right, getting closer and closer to the wall. Same deal. It appears that the curve is headed towards 1, that the value will peak at 1. And in this case, since these are equal, since in this case L, the right-hand limit equals the left-hand limit, we'd say that the general limit is also 1 that they've shared. If these are different, which can happen with some functions, that we would say that this does not exist. But in the case where they're both equal, the general limit exists and is the same as the limits from both directions.